Today we're going to take a look at section 8.6, solving equations with radicals. Only 3 examples today because there's no real new notes today, just some new techniques you're going to want to look at to solve these equations. There's only 1 or 2 more landmines to look out for, and I'll let you know when those come up. So here's our first example, root 5x minus 1 plus 3 equals 0. The first thing you need to do to solve these guys involving radicals is you need to isolate the radical, which means that I need to get the negative 3 over to the other side of the equation. So I have root 5x minus 1 equals negative 3. Once you have the radical isolated on one side of the equation, the big step here is that we are going to square both sides of the equation. We want to undo that radical, we want to get rid of it, and squaring is the inverse operation of the square root, so therefore that will remove the radical. The square and the square root sign here somewhat cancel each other out. On the left hand side I have 5x minus 1, and on the right hand side negative 3 squared is 9. And from here this becomes a fairly easy equation to solve. Just add 1 to both sides. 5x equals 10, so therefore x equals 2. One thing that is important in these problems is you really do need to check your answer, and you'll see why that comes up in one of the later examples, but you do need to check to make sure your answer works. So I'm going to plug 2 back in. So if I plug 2 in, I'll get 5 times 2 is 10 minus 1 plus 3 equals 0. And we see here that we get the square root of 9 plus 3 equals 0, and that's interesting because we get 3 plus 3 equals 0, and clearly that's not true. So therefore, x equals 2 is not a solution, and actually this equation has no solution. So sometimes this situation will arise, and when this happens, we say that x equals 2 is an extraneous solution. It's a solution we got from an equation after we squared both sides, but it's clearly not a solution to the original equation, so it's called extraneous. So again, the only solution we have, actually we have no solution, is that there is no solution to this problem. Okay, second example. Radical 4 minus x equals x plus 2. Again, we're going to square both sides of the equation. Square both sides. On the left-hand side, that means that we have 4 minus x. On the right-hand side, we have to do x plus 2 squared. That's a pattern we know well. That will be x squared plus 4x plus 4. Now I'm going to gather all the terms on one side of the equation. I like my x squared term to be positive, so I'll keep it over here on the right-hand side. X squared, we move this x over to the other side. We'll have 5x. We will subtract this 4 from both sides. Oh, that's a good thing because it causes our 4's to go away. And I have x squared plus 5x equals 0. Little GCF action here. X times x plus 5 equals 0. And 2 solutions appear, 0 and also negative 5. And we do need to check both of those in the original equation. So let's check 0 in the original equation. I'm going to change colors here. Let's check 0 in the original equation. If we check 0, on the left-hand side we will have square root of 4. And on the right-hand side we will have 2. And clearly square root of 4 is 2. That equals 2. That checks out, so 0 checks out. What if we plug in the negative 5? On the left-hand side, we'll have 4 minus negative 5, the square root of that, so square root of 9, equals negative 5 plus 2. That's negative 3, and notice what happens here. We're only dealing with primary roots. Square root of 9 is positive 3. That does not equal negative 3, so therefore negative 5 is an extraneous root, and the only solution we have is 0. So you do have to be looking out for those extraneous roots. One last example here, and I'm a little bit worried about this one because I will warn you up front that this one takes more work to do than the rest of them. It's going to take a lot more space, and you'll see why in a minute here. But first of all, I do need to isolate my radical. Well, I have 2 radicals here. So the trick is I do need to move one of these radicals over to the other side of the equation. So I'm going to go ahead and do that. So I have root 5x plus 6 equals 2 minus root 3x plus 4. And now I can go ahead and square both sides. Square, square. And some nice things will happen here, but one unnice thing is going to happen. Left-hand side, 5x plus 6 equals, I am squaring really a binomial here. I have 2 terms. 2 squared is 4, but I'm going to have in the middle here, I'm going to have minus 4 root 3x plus 4. And then at the end, I will have plus 3x plus 4. Now, you might want to take a minute and verify that that work is correct there. I really just did a minus b squared. So the problem here is I still have a radical floating around, but instead of having 2 radical expressions, I only have 1. So I'm going to go back and repeat the original procedure, which is I need to get the radical alone on one side of the equation. So I'm going to take this 4, this 3x, and move them to the other side of the equation. So 4 and 4 is 8 When I move that to the other side of the equation, I'll have negative 2. I also have 3x I'll move to the other side by subtraction. So I have 2x minus 2 equals negative 4 root 3x plus 4. Okay? One last thing it's probably a good idea to do as well is to get this negative 4 over to the other side. And I can do that by dividing. So I have 2x minus 2 over 4 equals root 3x plus 4. So you see why I was a little bit scared of the amount of room I had in this problem. And I can simplify this left-hand side. This is just x minus 1 over 2 equals root 3x plus 4. So I am running out of space a little bit here, so we're going to see what we can do here. But now I'm ready to square both sides. This is going to come out a little bit nicer here. So I'm going to square. Hopefully it does anyway. I'll have x squared minus 2x plus 1 over 4 equals 3x plus 4. Okay, I'm going to take my work and I'm going to move it. I'm running out of space here. I'm going to move it up here. I'm going to take this 4 and multiply it over to the other side. So it's just some cleanup work here. X squared minus 2x plus 1 equals 12x plus 16. Let's move some things around here. Move the 12x and the 16 to the other side. X squared minus 14x. Let's see what I have here. Minus 15 equals 0. And we hope and pray that that factors. Which it clearly does. We have x minus 15, x plus 1 equals 0. So we have two potential solutions here. X equals negative 1, x equals 15. And I'm going to give you a minute now to check and verify both these solutions and see if they fit. Remember, we need to plug these back into the original equation. So let me give you a minute to do that. Okay, so hopefully you've had a chance to plug both of these in. I'm out of space here, so I'm just going to hope that you're able to do this. But what you should have found is that negative 1 is in fact a solution to the original equation, but 15 is not. So therefore this only has one solution, and that is negative 1, and we look very Christmassy. So only 3 examples, not a lot new going on here. You do have to square both sides, make sure you isolate that radical, and check your solutions.